Hello, welcome to Sharmit. In the previous session, we have seen that how we can design the subfile. Now in this session, we will see how we can create a RPGLE program to use that subfile. Okay, so let me show you the output again. So this is the subfile that we have designed in previous session. Now we will see like how we can load this data and how we can populate this subfile in this way. Okay, so for the same, here I have created one program that is AMPPFR. Now I will take this program in edit mode and I will show you the program one by one. Okay, so first of all, what I'm doing as usual, like I'm setting the control option for debugging purpose, and below to that, here I have declared two files. My first file is the display file. So to declare the display file, we usually like write like this dclf and display file name. Then this is the keyword for display file, that is workstn. Then we are using one keyword, that is sfile, to define the subfile. And here we are passing the subfile record format name with one colon and the value. So this value is mainly used for the relative record number, so that's why I'm giving the name as rrn. Okay, you can put any name, but whatever the name you are using here, you have to use the same for accessing the record or for incrementing your rrn value. Okay, now below to that, we are declaring one file, one physical file in both mode, like input and output mode, and it is keyed file, so we just write keyed. So these are the file declaration. Below to that, we have declared one variable that we are using here, that is rrn. So it is numeric of type, numeric type, or 4 length. Okay, now main logic started from here. So now we will talk only on the subfile portion. Okay, so what is subfile? Subfile is a way to show the data in a tabular form on the display file, uh, display screen. Okay, so to display the subfile, or to process the subfile, we have mainly three processes. Okay, so first one is clear subfile, second load subfile, and third is display subfile. So these three processes will be executed to populate that subfile on a screen. Okay, now we will see one by one. Okay, so here I have stored some information about the indicators that we are going to use. So if you remember, in the last session we have set few of the indicators, that is SFLN, clear, SFLDSP, and SFLDSP-CTL. So these are, now we will going to use this. Okay, so let's see the first one, that is clear subfile. In clear subfile, why we are clearing subfile? We are clearing the subfile because whenever we want to insert some data on the subfile, before to that we have to clear it, otherwise we will not be able to put the data. Okay, so let's see the how we can clear the subfile. So first of all, we have to set the rrn as 0. What is rrn? Let's say we have this space and we want to insert some data here. Let me turn off this cross indicator. Okay, so suppose we have this portion, and in this we have spaces. We have spaces for 5 rows. Okay, so my first row will be pointed as rrn1, then 2, 3, 4, and 5. So this is relative record number. So initially what I'm doing, I'm setting my pointer to rrn0. It means my row is not set yet. Okay, so whenever we are going to write the subfile, we will pick we will set the rrn, and then we will load the data that we will see in the next subroutine. So I have set my rrn as 0. Then I'm turning on the indicator, that is 91. So what is 91? 91 is SFL clear. So once this indicator is turned on, my SFL is clear. After that, we are good to write the control portion, means the header portion. So I'm just writing write DSP-CTL, and below to that I'm again turning off my clear indicator. Why? Because if you do not turn this indicator off, then it means like it will try to write it will try to clear the data whenever we are going to write the data. So these two operation create a conflict and will give error. So that's why for a safe side we are clearing the subfile, and then again we are turning off the indicator. Okay, now this is clear routine is done. So here mainly we are setting the RN as 0, then we are turning on 91 indicator, that is as well clear. Then we are writing DSP control portion, and then we are again turning off this indicator. So this indicate routine is completed. Now the next part, in next part we are going to load the data on the subfile. So how we will do it? First of all, we will read the data from PF from which we want to get the data. So here I am setting the my pointer to the lowell value in AMP data file. Then I'm reading the data from it and till the file is not empty. Okay, so percentage end of file, not end of file. Okay, now we have to set the RRN value. Okay, so in previous subroutine we see that if RN is set to 0, now here we have to set the RN value by incrementing it. So if we have 5 space in a sub file, so what we will do, we will set the pointer to the first RN. So right now my RN value is 0, so it will become 0 plus 1 1. So now RN is set as 1, and for first relative record number I am writing the data. So these are the field that we have defined in subfile that initiates with S1. Okay, so the prefix I am using S1 is for this for the fields that we have declared in subfile. Now we will write data. So these are my PF fields and these are my subfile fields. So I'm just evaluating those value one by one. So I'm writing EMP ID in S1, EMP ID, EMP name, and EMP department. So now for relative record number 1, data is in moved. Okay, now on line number 63, what we are doing, we are just checking the RRN. If RRN is become the greater than tetra 9, then we have to leave this loop. Why? Because the maximum allowed size for the subfile is tetra 9. If it exceeds that, then we have to leave the routine. We are not able to write the data, otherwise it will give error. So that's why we are writing a logic like if RRN become is greater than tetra 9, then we have to leave the loop. All right, below to that what we are doing, we are just writing the DSP assemble. Now we are writing the buffer because we have set the data. Now we are writing the buffer, and again we are reading the PF because we are reading that PF into loop. So we will write read EMP data. Below to that we are also checking one more condition, like whether, like if my end of file is occur, like if my file is ended, then we have to turn on this indicator, that is star IN90. Why? And which indicator is it? Is for SFL end. So it will show the user that yes, here the SFL is ended. So that's why we are turning on, and otherwise we will keep it as off. Okay, and then we are ending the loop. So in this way, load also file read the data, increment the value. Now RRN become 2 again because we are done with for the first one. Then it will become 1 plus 1 2, and one by one it will write the data for all RRN as much we have in data in PF till tetra 9. If tetra 9 RRN become tetra 9, then it will leave the loop, and then we are just writing the DSP SFL part. So this is the functioning of this routine, that is load routine. Now we will see the last and final routine, that is display subfile. Here what we are doing, here we are just turning on two indicators, that is SFL DSP and SFL DSP CTL. So you can check it here, SFL DSP and SFL DSP CTL. So just turn on those indicator and then check one more condition. If RRN equals to 0, then we have to turn this indicator again off, otherwise it will give the session or device error. Okay, so why? Because if RNN is 0, it means we don't have enough data to display on the screen, because RNN will only increment in case of data, if we found the data. If we check the previous logic, so you can easily identify we are incrementing RNN only when we got the data. If it is data is not found, then it will keep it as 0, because we have initialized this indicator as 0, right? This is 0 INZ. So if RNN is 0, in that case we have to keep this indicator off, otherwise it will give session or device error. Okay, so this is the condition that we have to check. Now what we are doing, we are just running one loop till the IN indicator is off. Like until the this indicator is off, we have to keep these function to be processed. Otherwise, once the IN03 is on, it will came out of the loop. What here what we are doing here, we are just assigning one s1 pgm name. If you remember, there is one field on the header portion, so we are just assigning our program name here. So this is the program name, and after that we are just writing the footer, that is the bottom part of our subfile, and then we are displaying the control part. So we are just again exfmt the control part. Exfmt, what it do, it just read and write. So it is a combination of read and write. So if I remove this line and if I write like in this way, read dspctl and write uh, dspctl, so it will also become the same. So here we have to exfmt the control portion, and just we are ending the do and routine. So this is how we can create the subfile in RPGLE program. Now let me compile and call this program again. So this is the program field in which we assign the data uh, for in the display routine, and this is my control portion, this is my buffer, and this is my footer. So if you want to check the indicators again, then you can check like here. In previous session we set these indicators. So these are the indicators that we set: 91, 92, 93, 90. Okay, so yeah, that's all for this subfile, and this is a load all subfile. There are few more subfiles in RPGL and AS400 that we will see in the upcoming sessions. And mainly today we see only the program part of the subfile, and in our previous session we see the display file. So yeah, that's all for this session. Thank you for watching TechSharmit.